Hello, my name is Randi Butler and I'm a FFAR fellow at NC State University studying geospatial analytics. Imagine that you are preparing to take a vacation. You're packing nice clothes and outfits for your trip, but you want to know what the weather will be. Your first thought is to look at a weather app. You check one and it shows it'll rain during your stay, and you check another and it says the opposite. Imagine the confusion you will have about the weather. You basically have to double pack just to prepare. You wonder how is this possible and which one to trust. Well, the reason for this difference is based upon the predictive model used and the data input for whichever app you're using. Usually weather applications get more accurate closer to the actual date, but this can still be bothersome. Now imagine that you are a farmer trying to understand your crop yield within the season based on weather patterns and climates. What do you look at? What's the best resource, and are they accurate? This is what my study seeks to solve. In the field of agriculture, there are many predictive models or forecasts, and they are highly variable due to the data input, just like weather forecasts. In weather, inputs are based on satellite imagery, radar, and on-ground sensors that track wind speed, precipitation, humidity, etc. Whereas agriculture models can be based on a multitude of things such as historical yield, current reported planting, climate, soil health, and more. By focusing on the inputs, we can make a better model. One of the most important inputs is raw data. Most agricultural models heavily rely on agricultural census and survey data, which is participation-based. Census and survey data provide the raw data about what's planted and harvested, just like ground sensors provide raw data for weather forecasts. Unfortunately, since 1990, census and survey participation has decreased to 60% or less, therefore making that data unreliable. This huge portion of data that majority of models are created using is causing forecasts to become inefficient. My research proposes using a different source of raw data reported by crop insurance. There are 287 million acres of cropland in the United States, and 85 to 90% is covered by insurance. Why is this a more reliable source? Unlike the census and survey, the input of this raw data is mandatory, as it is a requirement of insurance coverage. We have found that there's a significant difference in the number of locations reporting crop data by insurance versus the census and survey. By changing the raw data source, we can make a more accurate model that can provide a better understanding of what the expected yield outcome would be for an area because we now have more data. We can then plug this information into a new model which utilizes weather, climate, satellite imagery, and more to identify areas that are highly likely to experience loss in yield, much like a weather forecast which shows the probability of locations to experience inclement weather. By doing this, farmers will be able to properly plan and prepare their resources to keep their crops healthy and protected with more certainty. And they will also know which model is more reliable to use in their crop plans.